In this video, we'll discuss the problem composite and prime. So we are given with two numbers L and R, and we have to find number of composites and primes between the range L and R. We have to find a difference between the number of composite and prime. Okay. So obviously, if a number is not composite, then it is a prime, and vice versa. If a number is not prime, then it is a composite number. If we can find that number of numbers between L and R which are primes, or if we can find the numbers that are composite in this range, then we can also find the prime ones. So we all have learned about that how we can find prime numbers in a given range. For that, we can use the algorithm. We can use the algorithm. So how we can just implement the sieve for finding that how many prime numbers are there, or basically if a number is prime or not. So for that, what we can do is that in C, what we do that we can find it is a very efficient way to find the, that till number n how many prime numbers are there. Or basically, if we have to find that between 1 to n, we have to find for the numbers which are either prime or not, we will use the Sieve algorithm. So how it works? Let's take that n is 15. That means we have to check that from number 1 to 15, what numbers are prime and what numbers are not prime. So in a start, what we will do, we will take a, a Boolean array from 0 to 15, 0, 1, 2, or basically 1 to 15. But because arrays are 0 biased, I'm taking from 0. Now, so currently all the values of this Boolean array, let's say it is true, because it is a Boolean array. So all the values are currently true. Now what we will do is that we will make the 0 and 1 as false. Why false? Because we all know that 0 and 1 are not prime, not composite. Okay. Now what we will do that we will just start from the first index, the first value, and then what we will do according to the Sieve algorithm, we will make all the factors of that value to false. So because we have taken 2, so all the factors of 2 which are in this range means less than equal to 15, we will make it false. So it is 4, 6, 8, 10, 12, 14. Similarly, we'll check for 3, 4 also. We'll make the factors multiples of 3 to false. It is 9 and 15. Similarly, for 5 also, but for 5, the multiples are already false, and for 7, 11, 13 also they are false. So let's say we are finding for some more value. Let's say from 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So first for 2, it has also crossed for 16, 18, 20, 22 and 24. Then for 3, it should have crossed for 15 and 18 and 21. Okay. And then for 5, it has been crossed for 25. Then, and we will not take that numbers which are already false, like 4 and 6. We will not take them. We'll just skip them. Then for 7, all the numbers are, I think, already crossed. Then for 11, all are already crossed. Okay. Then we will not move forward. So basically, if we have to find till number n, we take this loop up to sqrtn also. Because after that number, all the multiples of the remaining numbers are already false, and that remaining numbers are basically the prime numbers. So this is what we have to do. Now, let's implement this sieve. Okay. So to implement this sieve, what we will, because here we have to find number of prime numbers till r. It's between the range of L to R, but in sieve, we basically find from 1 to L. So we'll find from 1 to R only. For that, we will take a vector of Boolean data type. Okay, let's name it P, and the size will be R plus 1. Initially, they all are 2. Then what we will do, as I told, that we have to make the value of P0 to false and P1 to false. Then we will take a loop from 2 till, as I told you, will be sqrtr and I plus plus. Then for this I, what I will do, I will make all the multiples of that I to false. For that, what we will do, we will take another loop J, where we basically start from I into y. So it's that we will start from I into y only, because you can see that, let's say for this 3, it's 6 was already crossed because it was crossed by 2. So we used to start from 9 only. For 5, you can see the first cross was from 25 only. That is also another logic. That is normally a C algorithm. I hope that you all have learned. Okay. Now, this is what here it should be R. It should be equal to R basically. And then we make the value for that particular j is equal to false. That numbers are not prime because they are multiple of a particular number. And that numbers are prime, which are true. Now, what we will do, we take a value p, or let's say prime is equal to 0. Let's take a value for composite numbers. Then it will basically take a loop from L to R. Also, one more thing which we have to consider, that as we know that 1 is neither a prime number nor a composite number. In case that we will encounter a 1, we will just continue. Else what we will do, that if the value of that I is equal to means that is a prime number, we will increment plus, else we will increment not p, it's prime. We have taken the prime, otherwise composite plus. And at the last, we have to return the difference between the prime numbers and composite numbers. So it will be that we can just store that in the answer. It will be ABS of prime minus composite, and we can just return this answer. Let's compile this code. Okay, so it has got some wrong output. Like for our output is 3, but it should not be 3. So it's like that we are having some problem here with our code. So let's just figure out the problem what we are having. So yeah, we have initially made it to true, and then we have got the false and false. Then what we can done, that we have just taken the loop from int I is equal to the sqrt of r. That is also good. Then I've just started from I into I and got up to r. Then I've just checked. Okay, so there's one mistake I've done. The mistake is that if the number is already crossed, we have to not check for it. We have to not check for it. So if the value of a number is equal to false, then we'll just continue. We will not check for that number. That's also a case which we have to consider. And another case is that here we have made j plus plus. So that was a mistake from my side. In the C algorithm, it will be j plus is equal to I, because we want multiples of I. Now let's compile it. There was two silly mistakes from my side in the code. Okay, this is how we basically debug the code. Okay? That is why maybe the time complexity was also getting large. This is what we have done, right? Okay. Now let's take a custom input. Let's take it from 2 to 100 and then compile it. Let's see that what will be the answer for that. So yeah, we have got the correct output for it. Now let's submit this code. So here we have got some wrong answer. The thing is that we have to not output the absolute value. We have to just output the difference between the composite and prime. So what I will do, that I will just make it here composite minus prime. So now if I will submit it, now it should give the right result, because it is just wanting us the absolute value of composite minus prime, not the normal value of it, and not the absolute. So yeah, it has had got the right answer. And if we talk about the other complexity analysis of it, so you can see that the space complexity for is something O of R. This is the space complexity. And for the time complexity for the solution is something, because here we are using a sieve, it's similar to the sieve, and here we are just iterating from L to R. It will be overall from L to R only, because sieve is just taking the SQRT of R into something again the log of I. Okay? This is the space complexity and time complexity for this problem, and these were the two. So the most common thing which we have to observe is that here we have to make the thing that we have taken for a sieve. We have not making it plus is equal to I. We have just incremented it, and the thing was that if it is already false, there's no need to call for this function and just continue. Thank you. I hope you have liked this video. If you have any doubt, you can comment it down. Otherwise, you can just like this video, share it with your friends, and subscribe to this amazing channel. Thank you.